This is the homework help video for problem 2-9 from the 2.1.1 homework. The directions are: state whether each graph is a function or not, then state the domain and range. We've been doing this a lot at chapter 1, so hopefully this one should go smoothly, but if you're needing help, make sure you're listening. Okay, let's look at problem A first. To determine if it is a function, remember, each input may only have exactly one output. And we learned about the vertical line test to determine or help us see if there are any inputs that contain more than one output. That means you would have points that would be directly above and below each other. So I drew out this little vertical line here, and I'm going to use this to kind of trace over my graph. Now, if my blue graph, right, if you see it as I'm going across here, if it touches that function, that little squiggle, more than one time at any point in time there, then it is not a function. And you say I went all the way across there and it never touched it more than once. Let's look at B, right? You look here, it is not touching that W shape at more than one point ever, right, as I go across here. So looks like both A and B are functions. But when we get over here to letter C, you'll notice as I start tracing it from left to right, it's intersecting my graph in two places. Therefore, this one is not a function. This one fails the vertical line test. Okay, so we can say here, is this a function? Yes. Letter A is a function. Letter B was a function. And then we'd say no on letter C. We could say it fails the vertical line test. Okay, so now let's talk about domain. When we look at A, you notice we have these arrows on the end, right? It's got that arrow on the end there, and then it's got that arrow on the end there, which means that that shape is going to continue to go forever to the right and to the left, right? And remember, out here to the right, that's positive infinity, and out here to the left, that's negative infinity. So this graph is going to continue to go in both those directions. So when we're talking about our domain, our left side is negative infinity. Our right side we know is positive infinity. We'll throw our x in the middle. And remember, you can't equal infinity. It's not a number, it's just a math concept. So we are only going to use the less than signs. We are not going to use the equals. So our domain for that first one is negative infinity to positive infinity. Or you could also state that that is all real numbers, which we learned, right? The all real number symbol. Okay, then let's talk about its range, right? Where our domain was talking about the shadow that's left on the x-axis. But if we look at the shadow that's left on the y-axis, right? Well, it looks like our top point goes up to here and our bottom points go down that far, right? So it looks like this one's going to go from 1 all the way up to 3, and that's it, right? So we'll say our bottom value, right, is 1. Our top value is 3. We're talking about y's right now. Now, remember, this is a collection of points. So all of these are points as you're going along here. So we actually have a point. So we want to make sure we're using an equal sign. We'll say 1 is less than or equal to y, and y is less than or equal to 3. Looking at letter B. Again, we've got arrows going to the left and going to the right. So it's going forever to the left, which is like negative infinity. It's going forever to the right, which is positive infinity. So again, we have all real numbers. And again, you could use the all real number system or symbol if you'd like to. Then our range, right? So again, our domain was all of these. Our range starts down here. Our lowest point are these ones, right? So it starts down here and then it's going up, right? And if these arrows are going up forever, right, that means it's going to continue to have y values that are higher and higher and higher, which we know at the very top of our graph, that is the same thing as positive infinity as well. So we're going from down here all the way up to there. So it looks like we're going to say 0 to positive infinity. As we write that out, actually I'll write that in blue since I wrote the other part in blue, right? This is 0 to positive infinity. There is a point down here at 0, so we'll say 0 is less than or equal to y, and y is less than positive infinity. Now let's look at the domain of the last one. If we look at the shadow that's cast from this on the x-axis, right, since we have the arrows, again, right, there's an arrow on this one and there's an arrow on there. I know they're small, but that means that this graph is continuing to go out this direction, which means our shadow would continue to go out that direction, but it would only run all the way to about right here as we go to the left. So that looks like we're at the point, what is that, -2? And then as we run out to the right, we're talking about positive infinity. So our domain is going to end up being from -2 to positive infinity. And we can include -2, but we can't include infinity. So we will not put an equal sign on the infinity side. And then our range, right, even though this arrow looks like it's going only to the right, and this one looks like it's only going to the right, it's gradually still going upward, and this one's gradually still going downward, and it will forever. So at the bottom down here, we have a negative infinity, and at the top, remember, is positive infinity. And that shadow that's going to be cast is going to go from down here all the way up to there. So as we write that out, we'll say negative infinity is less than y, and y is less than positive infinity. And in other words, again, right, that's the same thing as all real numbers. All right, and actually we're going to go ahead and do 2-10 because it's asking about this same problem. It says examine the graphs in problem 2-9 again. It says which, if any, have lines of symmetry. Okay, now it doesn't ask us to get real specific about what the lines of symmetry are, but if we look at our first graph, right, and we're going to assume that it's going to continue to go up and down like this. So this one could have some different lines of symmetry because it's going to continue to go on and on and on in both directions. And if you see here, if I took it and I said, hey, I'm going to cut it like, let's say right here, right through one of those minimum values, right, you can see the reflection of the graph, right? You can see this reflection as it goes out this way and goes out this way. It's kind of a mirror image of each other. So you've got it there, or, right, you could also drop in a line of symmetry through any of those maximum values. Right there, you'll see here, right? So it would still cut that graph and then make it a mirror reflection. So we know that letter A has symmetry. Looking at B, B is also going to have a line of symmetry. If we take that W, right, and we split it in half, just like that, right through there, right, you'll see it reflects across. So while A has multiple lines of symmetry, right, B is only going to have one, right? B has a line of symmetry at, try to look at where this is located here, right? This looks like this is where our x is 1. All the points on this blue line that I'm drawing in have x values of positive 1. So we'll say that would be x equals 1. And then as we look at our last one, it's kind of laying on its side. So if I was to look for a line of symmetry here, I think we could draw one in horizontally on this one, right? Run right across here. And now you see the top half and the bottom half reflect upon each other. So how do we write that? Well, let's see here. we've got letter C. All right, this is letter C. And we'll say yes, this one has a line of symmetry. And to draw in a horizontal line, right, we're talking about all of these have the same y coordinates where y equals 1. So the line of symmetry is where y is equal to 1. And that is it for 2-9 and 2-10. Oh, I guess it wanted us to draw them in, but we already drew them in. Whoops, let's put that back. All right, if you have any additional questions, please make sure you ask. Thanks.